Okay, sir.
All right, 11. 11 says the elements in group 17, the halogens and their compounds, show many similarities in trend in their properties, and that are given for the elements of fluorine to iodine. So we have the elements, and then we have the bond energies, the enthalpy range of atomization, boiling point of element, boiling point of hydrogen halides. Part A says chlorine reacts directly with many elements to form chlorides. Three such compounds are MgCl2, AlCl3, and SiCl4. Number one, state and explain the pattern shown by the formulae of these three chlorides. Do you find this one difficult?
No,
Or
so like
which
I know
part
the
in specific?
oxidation state is increasing by one, but like how do I explain it?
You're right with the oxidation state or the valency, and since it increases, the number of chlorine atoms also increase.
Okay,
You're
so
right
that
with
will
your
be enough.
point. Yeah,
Yeah.
that would be
Mm-hmm.
enough. Actually, your point can get you going 1 mark, but you are supposed to tell them that in these formulas, since they're reacting with chlorine and they're all forming chlorides, and number of chlorine atoms per formula is different. For example, for Mg it's 2, for AlCl3 it's 3, and for SSCl Si it's 4. So if you explain that the valency or the oxidation number increases from left to right, and that's why it's capable of doing this, you will get 1 mark for this, and number of chlorine atoms accordingly, another mark, both marks are done.
All right.
Okay, so moving on. Number two, write equations to show behavior of these chlorides in this added to water. This actually is taken right
Yeah, I
out of
was
the book.
yeah, yeah, I was able to do that.
Okay, so remember that for ionic compounds, they simply tend to dissolve in water if they are soluble, of course. But for covalent compounds, what happens is that they are going to form some other compound or probably give some ions out of it. And in the case of covalent compounds, they usually give some ions that are acidic. So at the end of the day, we have some acidic solutions at the end. All right.
All right.
If you keep that thing in mind, anything after ionic compounds that can be grouped 3, 4, 5, 6, 7, depending upon whichever one they have used, you will be able to come up with correct answers. Okay.
Okay, sir.
What else? Question 15A, second part. The element tellurium Te reacts with chlorine to form a single solid product with a relative formula mass of 270. The product contains 52.6 chlorine by mass. Calculate the molecular formula of this chloride.
Yeah, I did that.
So you should have gotten the empirical formula out of it. Then you must have calculated
Yeah, yeah.
empirical formula mass. Then finally the molecular formula after calculating N. So the molecular formula was
TeCl4.
TeCl4. Just to be on the safe side that if it's required. Now, this chloride melts at 224 degrees centigrade and reacts vigorously with water. State the type of bonding and structure present in the chloride and explain your reasoning. Now, this gives us the idea as well as this. Okay, both of the things connect to just one point. It's covalent. Okay, and this tells us it's simple covalent. Also, this tells
Uh-huh.
us the same
Okay.
thing. Remember, covalent molecules have lower melting and boiling points. Also, I just explained in the previous question that ionic tend to dissolve if they're soluble in water. On the other hand, covalent molecules tend to react. And if they are made up of nonmetals, what happens is that they tend to turn the whole solution acidic. And sometimes that happens in a vigorous reaction. So, yeah, a vigorous reaction. Since ionic compounds don't react at all, So the reaction must be occurring with a covalent compound. Since this tells us it only contains 5 atoms, so apart from bonding that is covalent, the structure must be simple molecular structure. Simple covalent or simple molecular covalent, that's fine.
All right.
Okay.
Yes.
The reasoning is for your understanding, although you can quote the reasoning over here, but stick to the bonding and the structure explanation first. Afterwards, if you get the half of the line or one line, then you can go ahead with the reasoning.
Okay. And for the equation?
Okay, so let's do this. TeCl4 plus H2O. Now, since I've already explained one thing, that they are going to turn the whole solution acidic, that's only possible if we make an acid out of it. All right.
Okay. We made it. Yeah.
So once you're done forming the acid, you understand this comes out of here. So what happens is that you connect the rest. Now there are two ways of doing this. Okay. So since water is made up of hydrogen and oxygen, so you may have this. And since this is showing +4, this is +4, this is -2. So the chances are this must be TeO2. All right.
Okay. Okay.
Okay, let me
Yeah.
do
Yeah.
it for you so that we don't have any confusions. Te2O4, simplifying this becomes TeO2. Make sense?
Yep, it does.
This is one way of doing it. Okay. There is another way of interpreting the whole situation. I just currently said that water is made up of hydrogen and oxygen. There is another way to interpret it, and that is water is made up of H positive and OH negative ions. Now, if H positive reacts with Cl to form HCl, then OH negative must go to Te in order to form uh, TeOH. But these answers may or may not be correct. So sticking with the oxide is a better way of doing it. I'm not sure whether TeOH4 is the correct answer or not. That is one way of interpreting it, but this is usually in case of the systems that are forming acids, not correct.
All right, sir. Got it.
So this might be a chance, but since we're unsure, we're not going to go with this. We're going to go with this. This is not risky.
Okay.
This is always a sure answer,
All
forming an
right.
oxide. All right. Can I clear it up?
Yes, you can.
Do we have other parts to discuss for the same question or some other question?
No, no. Some other question.
Okay, what is that?
Just a minute.
Take your time.
Question 18C.
Question number 18, C part. All right, 17, 18. This question refers to the elements in the section of the periodic table shown below. So we have first 4 periods without the transition element. From the list of elements, identify in each case one element that has the property described. Give the symbol of the element. So 18C, right?
Yeah, yeah, see. I just wanted to ask one thing about it. First part.
The melting
Can I
points
make
of
mention of the IMFs? IMFs, I mean.
just a second. Melting points of the elements Si to Cl are given in the table. Explain why the melting point of Si is very much greater than those of the other three elements. So you are talking about mentioning intermolecular forces, right?
Yes, for like phosphorus to chlorine, and for silicon, say that it has a giant structure, so that's why.
So since it has a giant structure, so it's more about bonding or the structure itself than it is of the other three. So what you're supposed to do is to start off with bonding. If you have enough space, which I really don't think you have, you can do that, but I don't think you have enough space. Okay, see it like this. There are four kinds of total crystals or structures in solids that we get. First of them are ionic
Yeah.
crystals. Then we have covalent, and covalent is actually divided into two types. We have covalent as simple molecular, and then we have covalent, which are macromolecular, which are simply also known as macromolecules. We also call it giant covalent or giant molecular structures. And lastly, we have metallic crystals. Okay, we have monatomic elements such as noble gases, but I'm really not discussing them since they're not in present in the solid form. Okay, so out of these, you need to understand that this structure, and this structure, whenever we melt them, we actually break the entire bonding, or we boil them. In this case, we need to overcome the intermolecular forces. So yeah, if that happens, go ahead and describe. But if we are comparing this with these, so you need to tell them that this is giant molecular, since he's asking specifically about Si. So giant molecular, and we have a high melting point because we need to break the entire structure. I mean, every single bond in the structure, every bond in the structure. It may be or may not be single bond as per the question. Okay, so that's why high melting point. If you still have space, you can tell them that these are simple molecular, and you just simply need to overcome intermolecular forces. But I think you don't have enough space. Now that really
Yeah.
depends upon the font and your writing style. Some kids actually do this trick that they turn their font smaller in order to squeeze more words into it until unless it's readable and sounds okay. I mean, seems okay. That is fine. But if you're making it too small, difficult to read, that is really not a good idea.
Okay.
Just a writing tip. Okay.
Yeah, it's clear.
Okay. Any other questions?
No.
Okay. For these specific chapters, and I mean inorganic chemistry, it includes chapter 10, 11, 12, 13, and most of them are based upon facts or figures. If you have memorized them, well and good. Go ahead, go as per your memory and do them. If you haven't memorized them, I would really appreciate if you take help from the book or whichever source you want to. Don't Google them, but of course, some hard formed book or that kind of support. You can take help from it, and you can always cover up the reaction with that help. Even this is a good practice as a start. As soon as you recognize that stuff, you start memorizing that stuff, then you can start ahead and do it out of your memory. And that's not cheating if it's a progressive exercise.
Right.
Means if you keep on copying from the book till the end of this chapter, that's definitely cheating. But yeah, if you take a little bit of a help at the start and then you get familiar and then you start doing on your own, then it's a progressive exercise. That's fine. That's not cheating.
Yeah.
That's actually learning and saving time. It's actually smart learning.
Yeah.
Go ahead. Let's start with question 1A. A part 1?
It would be hydrogen, the other product.
Great. Metal plus acid gives
For
us
the
salt plus hydrogen.
yeah, and for the second one, calcium nitrate decomposes to give us calcium oxide plus nitrogen dioxide plus oxygen. I'll
Good.
write it down because I think it
I
might
guess
need balancing. Maybe, I'm not sure.
now I have given you the annotation capability. Go ahead.
Yeah, just a minute.
All right, let's see. So 2 moles of calcium nitrate gives us 2CaO plus 4NO2 plus O2. Yeah, perfect. Go ahead.
For nitrates, the stability increases down the group.
Yes, that is correct. And why do you think it increases? Though they're not asking the reason over here, but
Um, I think it's got to do with the size of the ion, like it's reducing, so the attraction, wait, no, ion size is increasing down the group.
right, now you're right. First you
Yeah.
weren't, but now you're right. It has to do with size of the ion. Yeah, and also don't forget that they get more metallic down the group. So we have stronger metals or more reactive metals at the bottom of the group as compared to the top of the group in case of group 2. Okay, so number 4. Let's uh, zoom it out a little bit more since you might require the top of. Back to it. Number 4. That's too easy. Can we skip it? Because
Yeah, sure.
you already know it's CO2, it's H2O, it's CaCO3, and then you're gonna write CaCO3 twice. There you go. Your equation formed. A little bit of
Yeah,
balancing, if it requires, I don't know, but if it requires a little bit of balancing, then you're done. So that's about it. The next one
yeah.
is also from IGCSE. We know we use calcium
Is
compounds
it for
in agriculture.
neutralization
Yeah, of course.
of the soil?
Reducing the
Yeah, all
acidity of
right.
the soil or neutralization of the soil. Perfect answer. So let's move on to C.
For the first part, when one 2s orbital is mixed with one 2p orbital.
Mm-hmm. Okay. I would suggest one thing. Always be safe
Mm-hmm.
and never explain the shell number along with the orbital or the subshell. So stick with 1s and 1p.
All right.
Okay.
Mixing one
Uh,
s with one p orbital.
right? Because yeah,
Right.
we have worked with period 2 elements, but you may not working with period 2 elements in your exact question. If you're going to write the shell, make sure which element you're talking about and which shell is that. It may be 4s, It may be 3s, not 2s. Okay. So S and P is a good way of answering the question. If you think you require more accuracy or more exactness to the question, always put in the exact shell number apart from the subshell or the orbiter. Okay. And yes, you're right. Moving on. And let's
Alright.
give you some space for the diagram. There you go.
Can
Oh, we
you
still
enable that
have it.
update? Okay.
Yeah, I was just thinking about it because as soon as we disconnect, usually these options are withdrawn.
Yeah, they go away. Something like this.
What did you just say?
I said something like this.
Actually, the exact opposite. What you have done is that you have combined the smaller lobes. Well, actually, the bigger lobes combine.
Uh-huh.
The bigger lobes combine, the smaller lobes stay on two opposite sides, the right and left. And finally, we get a shape which I used to call toffee shape during my
Yeah, I
teaching
remember this.
lessons.
Yeah.
Yeah. So if you go with that, combining bigger lobes and then converting into a toffee shape, you're right about that then.
All right.
I think you would easily be able to draw it. So let's not try it now. Let's move ahead. D. Oh, that's a more question. The 2 in the answer portion, minimum mass of CuSCN 2, it's a little misplaced. To be exact, this 2 shouldn't be here. It should be here. Yeah, go ahead.
7.5 into 10 raised to power 5.
Uh, can you tell me a little bit of the solution so that I can follow it too?
For 1 mole of calcium cyanamide, we get 2 moles of ammonia. So if we have 1.50 into 10 raised to power 6 times of NH3, we need to see how much tons of calcium cyanamide do we need. So 1.5 into 10 raised to power 6 divided by 2, because the mole ratio is 1 to 2.
And so finally, the answer would be
7.5 into 10 raised to power 5 tons.
doesn't seem right. I'm missing something. Okay, let's try doing it again. So you're saying with every 1 mole of this, you get 2 moles of this.
Yes,
So have you tried balancing the equation? So
the equation will be given
3H2O.
below. Isn't it balanced already?
Oh yeah, this okay. 3 right, doing the same thing. So 2. Calculate the minimum mass in tons for this that is required to produce this many tons of NH3. So first you need to get the moles of ammonia.
We can't do it directly, like use the same 1 to 2 ratio.
How would you do it directly? I don't get that.
So we cannot. So like if the mole ratio is 1 to 2, but the mass will need to convert it into moles first.
If you do it directly, I don't think it's going to give you the correct answer. See, you need, first of all, moles of ammonia, which in this case is going to be 1.5 into 10 raised to power 6. Of course, we're going to convert it into grams into 10 raised to power 6, and we're going to divide the whole thing by 17.
Yeah, yeah.
It should
Okay, I
give
get
you an
what
answer,
we have to do. Mm-hmm.
but would give you the half the moles of this. Let's suppose you get X over here. So this X is multiplied by the MR of our CaCN2, that is of CaCN2. And of course, we're going to divide it by 2. Minimum mass in tons. So we're going to divide it by 10 raised to the power 6 as well. And then you get your
Yeah, I
answer.
get it now. All right.
Is it the same? Because to my guess, it isn't the same.
No, it's not. We have to convert it into moles first.
Right, right. Guess what is it then if it's not the same? Means is it a
It's
very small
coming.
difference or it's a big difference?
No, it's big difference. First, I was getting 7.5 into 10 raised to power 5. Now
And
I'm getting
now
3.5 into 10 raised to power 6.
into 10 raised to power what?
6.
6. Yeah, that's a big difference. Yeah, you're right. That's a big difference. Okay,
Yeah.
great. So now we get it. Moving on. Organic.
Can you skip this one now?
Yeah, sure. Can. And number 2. This whole seems too easy because as far as the color of precipitate is concerned, you'd easily be able to tell it, and you'd already know that this specific color belongs to this specific formula.
Yeah, like silver bromide and cream PPT.
Great. So, which means if you need to write the same, almost the same thing in part B, because you are supposed to form silver bromide in part B, so you would also be able to balance the equation. But go ahead and
Yes.
balance it. there is one tricky point in balancing of the equation. Let's see if you're able to get that. So go ahead and try doing part B.
We'll put a 2 before the AgNO3
Right,
and a 2 before the silver bromide, and then we'll just write MnO3 twice.
perfect. The only thing I wanted to know is that are you going to go for MnO3 or MnO3 twice?
Yeah, twice because
The,
it's a group 2, so the charge exchange the
good,
valencies.
good. But sometimes I've seen students forgetting the small piece of detail and even then missing the hint of MBR2 over here and here, which clearly gives the idea about group 2.
Yeah, group 2, yes.
Okay, the MR. I'm going to move it a little bit so that you can see. Oh, it's not just MR, it's also MR and M. You're going to identify the metal.
Um,
That 297.
yeah, just a minute.
I haven't made any calculations, but if you can jump to the element and that too correctly or accurately, I think you're doing it right. If not, then we might need to check it.
Yeah, I'm just. What's the value of iodine? I mean, bromines. 35, right?
No, that's for chlorine. Bromine is 80, but since we are at advanced level, it should be around 79.9.
Oh, yeah, yeah, 79.9. Yeah, is it barium?
So you're getting barium, right?
Yeah, 137.2 was the MR.
Then this must be right. If 137.2 is for barium, I don't have a periodic table
Yeah,
as
yeah,
well as a
137
calculator.
is for barium. So, yeah.
Yeah, that's fine. Point two is doesn't matter. That's as close as you get with practical calculations. Okay, part D.
So we'll say the greenish yellow color disappears, and reddish brown color of the solution forms for the first part.
That's right.
And for the second part, it's a displacement reaction.
Correct again. Part E.
We can add sulfuric acid, and then the observation will be that reddish brown liquid forms.
Liquid. A pretty exothermic
Bromide,
reaction.
yes,
It won't
yes.
stay in the form
Bromide
of
will
liquid.
be oxidized to
Right, right.
bromine. Yeah, yeah.
Make sure that you convert to concentrated sulfuric acid because dilute sulfuric acid
Okay.
cannot do the trick.
Yeah, yeah. Concentrated is oxidizing agent already.
Correct, correct. Moving on. So, how come were you able to identify that you can use sulfuric acid but no other reagent? Why weren't you able to use, let's say,
The
silver,
ammonia one,
uh, silver nitrate? Why not?
because the color white, cream, and yellow, they're pretty similar, so it's harder for us to differentiate between them.
What if I say that's not the reason? I mean, you're correct with the point that we are not going to use that, but you're not correct with the reasoning. What then?
Uh-huh. So you're saying why didn't we use the addition of silver nitrate?
Okay, let me clarify. Silver nitrate is always used when we acidify first. And we have a very big hint at the very start, a single reagent. Silver nitrate is never used as a single
Uh-huh.
reagent. We always
Because first
acidify
we
with
acidified with
nitric
nitric
acid.
acid.
Right.
Yeah, yeah, yeah.
So using
And then
nitric
we add
acid first
dicrosilver
and
nitrate.
silver nitrate after means we're using two different reagents and not one. That's why we can't use silver nitrate.
All right.
Okay. All right. So F, that's a big question. Whichever year is this, it used a whole big question from chapter 2 alone. This goes on and on. Which year is this, by the way? 421. Cambridge is keeps on changing the way they form their papers,
Yeah,
and they keep on doing it so that they are very hard to predict. And that's actually a good part
yeah, that's right.
on their end as
Mm.
well as on students, because repeating the same questions actually makes students dull, makes students more choosy
Yeah,
about the question. But giving them new questions every time keeps them more competitive and induces them to learn more, which actually is a good thing. Some lazy students might find that bad, but that's actually a good thing.
yeah.
Okay, this